Hello. Today, let's talk about reconstitution of non-injectables. And in this particular example, we are talking about feeding tubes. So in this first example, we have a 1/3 strength of Ensure of 900 milliliters by NG tube over 8 hours. So that means for over an 8-hour period, we're going to give a 1/3 strength of Ensure at 900 milliliters. So let's just talk about that. So let's talk about the fraction first. So we have this ratio here, and it says it's 1/3 strong. So let's just break it down just a little bit. The numerator, the top number, is going to represent what part is solute, and the denominator is going to represent what part is solution. Okay, so this states that we are 1 part solute and we are 2 parts solution. Oh, sorry. Said 2. I meant 3. Sorry, guys. 3 parts solution. Okay, so what this is saying is I do a particular example about lemonade. So the powder, the lemonade powder, right, would be my solute. And when I drink it, that would be my solution. My water that I mix with the lemonade is my solvent. So now we're talking about how strong it's going to be. This is going to be a weak drink, right? Well, we know that it's 3 parts solution. Well, how much solvent do we need? Well, we're going to take the denominator and subtract it by the numerator. In this case, we get 2 parts solvent. So this is just focused on the ratio part. But let's actually solve it. Let's actually solve the milliliters that we're going to have as a total solution versus the milliliters of the solute, milliliters of the water, the solvent. So again, this is just the ratio part, which represents the strength. All right. I'm going to erase this. So if y'all want to pause this to write it down, I encourage it, but let's erase it. All right. So let's go solve this. So let's find our solution. Our solution is going to be this 900 milliliters of Ensure. And it's already in milliliters, so we don't have to do any extra work. So 900 milliliters times the feedings, the number of feedings. Well, how many feedings do we have here? Well, when I go back and read this last part here, it says over 8 hours. So that means it's just one feeding because they're going to do it over a period of 8 hours. So I could put a 1 here, right? Which just gives me 1 times at 900 milliliters. So my total solution is 900 milliliters. Now let's find our solute. Our solute is going to be the strength. It's the ratio strength times my solution. So I got a 1/3 strength times at 900 milliliters means I got 1 times 900 over 3 milliliters, which gives me 3 goes in, well, 1 times 9 is 900. Excuse me, 1 times 900 is 900. 3 divided by that gives me 300 milliliters. So 300 milliliters is my solute. So in this case here, that would be my lemonade powder, right? Now let's find our solvent, my water, my dilutant. That's going to be the solution minus my solute. And my V, I have to be careful. My V's are not always looking like a V, so I have to like be careful. And I don't have the neatest handwriting ever, but if you ever have any questions with it, just reach out to me. Okay, so my solution is 900 milliliters, and my solute is 300 milliliters. And when I subtract them, I get in 600 milliliters of solvent. So that is my answers for that one. I do want to do another example. I wanted you to see the difference in number of feedings. So in example 2 here, we have a 1/3, or excuse me, a 3/4 strength of this isomil, 4 ounces by mouth. It says every 4 hours for 24 hours. So over here on the side, I would go, okay, 24 hours divided by every 4 hours, because this is every 4 hours, we're going to give 1 dose. Or you can call it feeding, times 1 feeding. Well, 4 goes into 24 6 times. 6 times 1 is 6, so it's 6 feedings here. Okay, so I need this. My next note is that I see that this 4 ounces is not in milliliters, so we need to convert that. So I'm going to do it in the whole process, but I'm going to break it down. So let's look at it. My ounces here, or my 4 ounces, represents my solution, right? Let's go ahead and convert that. You could do it later or now. Just be careful when you choose to do it, and make sure you multiply it out and divide correctly, okay? Now, my relationship between ounces and milliliters, I know for every 1 ounce, it's times 30 milliliters. My ounces reduce, right? With themselves gives me 1. 4 times 1 divided by 1 times 30 gives me 120 milliliters. All right. This is the part I was like saying be careful about. This is correct, but we also now got to multiply it by that 6 feedings, right? Because that's how many feedings we're going to have in that 24-hour period if we do it every 6 hours. So we're going to say 20 times, or 120 times 6 gives me 720 milliliters as my solution. Now let's find our solute. Again, our solute is the strength. In this case here is 3/4 times the solution, which is 720 milliliters. So we can say 3 times 720 divided by 4. You could do it in parts if you need to. You can say 720 divided by 4, which gives you 180, right? So you would have 3 times equals 3 times 180 milliliters. And then multiply that by 3, and then we get 540 milliliters as my solute. Okay. Now I have my solvent. I'm going to take my 720, which is my solution, milliliters, minus my 540 milliliters, which is my solute. And then that gives me 180 milliliters of solvent, which is water. Now, if you look at this, it makes sense, right? Let's take that fraction and let's break it down. That fraction tells me how strong the drink is. So my numerator is 3 parts. Let me write it a little bit different. Let's call it 3 parts solute. My denominator is 4 parts solution. So now I'm going to say 4 minus 3 is 1 part solvent. This makes sense that we get the answers we did, because so if we look at it, this is a very strong drink. So this tells me my solute, my isomil in this case here, is going to be more. It's going to be real strong versus my dilute in my water, my solvent here. So this makes sense. That's what this fraction is trying to get us to recognize, is this actual strength of the medicine or the feeding, whatever that we're administering through a non-injectable reconstitution. So it may be oral, it may be through a tube, however it has to be done. And so, and the one above, you see it's 1/3. So if you look at it, oh, the solute was less, right? And the solvent was more. So this fraction here the strength is very important. That ratio is important. Thank you.